Hello, my name is Sonone. In this video, I will talk about very interesting manufacturing process which is additive manufacturing. Many times it is called as 3D printing. 3D printing is an automated additive manufacturing process where a 3D printer creates a physical model based on digital data. There are a number of various 3D printing technologies, but the most commonly used one called FFF or FDM. FDM is the most widespread and most affordable 3D printing technology, suitable for printing functional or mechanical parts and prototypes. The printer uses strands of plastic as the main resource. The spool of plastic is called filament and it is available with the diameter of 1.75 mm. Compared to liquid resins or powder materials, filaments are safe and easy to work with. The downside is that the layers on the printed objects are visible to the naked eye. The usual layer height if we are using a 0.4 mm nozzle is between 0.05 to 0.03 mm. Now let's go through the process of designing, slicing and printing of parts or prototypes for FDM 3D printers. There are many things that we should keep in mind while designing the parts which are to be 3D printed. First, we should try to minimize the need of supports. 3D printers cannot start printing mid-air and massive O-rings require supports as well. To save time, material and improve the quality of the object surface, try to design the object in a way that will minimize the need of supports. Second thing is, we have to decide how the model will be positioned on the print bed. Surfaces placed on top of supports won't be as smooth as surfaces placed directly on the print bed. Next is, consider splitting the model into multiple parts and then find optimal positions for these parts on the print bed. Let's take a simple sphere as an example. Printing it as a single part is quite difficult because the initial layer that touches the print bed is very small. You can add a brim and supports to fix this issue. However, the surface quality will suffer. Possible solution is to cut the sphere into two parts, print them separately and then glue them together. A circular hole printed vertically won't be perfectly circular. To achieve a better result, print circular holes horizontally as shown in this picture. When modeling parts that should fit together, you need to include certain tolerance. You won't be able to combine two parts with zero tolerance dimensions. Please keep in mind that you will probably have to tweak the tolerances until you reach an optimal result. Don't worry about not nailing it the first time. It will take a couple of tries to tweak everything. After all, 3D printers are designed to be great prototyping machines. So keep iterating until you find the best result. After designing the part, we have to choose the printing material based on our application. A common misconception is that various filaments are just about different colors. The truth is that there are many different types of filament with greatly different properties. Some materials are very easy to print and allow plenty of detail on the printed objects, but their heat resistance is low. Other materials can be the complete opposite. After choosing the material, we have to slice the model for printing according to material, because different materials need different print settings. Slicing is the process of turning a 3D object into a machine code called a G-code using a software tool called a slicer. The most common slicers are Prusa Slicer, Simplify 3D, and Cura. The input for the G-code generation is not just a 3D object, but various settings come into play as well. They can affect the G-code or printing process in number of ways, like the toughness of the model, amount of details, or printing speed. It's also possible to modify the object using scaling, rotating, cutting, and other tools. The software is as important as hardware, meaning that correct slicing settings are crucial for a good-looking 3D print. It is a simplified 3D slicing software. It is developed independently, so it's not tied to any 3D printer manufacturer or specific model. It features pre-made profiles for hundreds of variants of 3D printers. This is especially useful if you have more than just one brand of 3D printers, since you don't have to create printing profiles yourself. Let's see some basic slicing settings in this software. First is layer height. Sometimes it is also called as the Z-axis resolution. It has a major impact on both print times and overall surface finish of the printed object. Higher values lead to faster prints and more visible layers on the surface of the object. Most of the time, layer heights of 0.15 mm to 0.2 mm are preferred. Horizontal shells or solid layers, which are used to configure the number of top and bottom layers of the model, which will be completely solid. Vertical shells or perimeters. These are the outside walls of the model, and by setting the vertical shells, we are adjusting how many parameters there will be. Next is brim or skirt. One of these is used to increase the adhesion of the printed object to the print bed. When printing small or thin objects, it is recommended to use a brim. It's an additional flat surface that will prevent the object from warping or detaching mid-print. It can be easily removed when the print job finishes. Raft is a special kind of support structure which lifts the whole printed object above the printing platform. It helps to prevent warping or lifting the object from the print surface. Next is infill, which affects the print time, durability of the printed object and filament consumed. Infill is set as percentage, while 0% means a completely hollow object. Usually 10 to 20% infill is used. It's also possible to choose the infill pattern. Supports are scaffolding-like structures that support overhangs or parts that start mid-air. Supports are designed to be easy to remove, but they may leave marks on the model. Our goal should be minimize the number of supports. Fewer support means faster printing and better overall look of the model. Next is filament and print bed temperatures. Every filament manufacturer states the optimal temperature range for their filaments. We should stick to the recommended values. Modification of print temperatures leads to change of print visuals. The temperature of the nozzle and print bed usually ranges from 200 to 240 degrees Celsius and 60 to 100 degrees Celsius respectively. Next is cooling. It is recommended to actively cool printed objects, especially thin and tall structures, which don't have enough time to cool down on their own, because the extruder tends to stay in one area for extended periods of time. Speeds. In this section, we can adjust different speeds, such as speed for parameters, solid layers, support structures, and axis movements. Next is bridging. This is the only case when the printer can print in the air with no supports underneath the layer. This is a special case though. The extruder can drag a string of extruded plastic in a straight line between two solid points. After slicing the model, software gives the preview of the model in toolpath format. It also calculates time and material requirement for the print job. From there, either we can start printing process over the USB or we can save the toolpaths in the memory card. Now let's see the whole process, from designing to printing and also the post-processing through the example of FCC structure.